You ever scroll through your TikTok feed and just wonder, how does it know? Well, it's not just some magic algorithm. It's a mountain of data. I mean, a truly mind-boggling amount. And today we're going to pull back the curtain on the incredible engineering that makes it all work. Specifically, a new technology from ByteDance called bullion.
Okay, so just to put this into perspective, get ready for this number. Some single data tables at ByteDance are bigger than 1 exabyte. An exabyte, that's a billion gigabytes. Storing that much data is a problem in itself, sure. But actually using it, making it fast enough for AI, that is a completely different ballgame.
And right, that's really the heart of the issue here. It's not enough to just have the data sitting there. To power your For You page, to figure out what video to show you next, the AI models have to be able to get to that data and make sense of it, like right now, instantly. And that's where things start to get really, really complicated.
So to really get why this is such a big deal, we actually need to take a quick trip back in time. See, for ages, the data world had one main way of doing things. But then, back in the 2000s, there was this huge shift, a revolution really, that completely changed the game for data analytics.
So, what was this big change? It's all about how you organize the data. Think of a giant spreadsheet. The old way, called a row store, saved everything one row at a time. So like all of my information, name, age, city, is in one chunk. If you wanted to find the average age of all users, the computer would have to read everyone's entire profile just to pick out that one little piece of information. Super slow. The new way, the column store, totally flipped that script. It stores all the names together in one block, all the ages together in another, and so on. So now, if you want all the ages, you just grab that one column. Boom. For analytics, this was an absolute game changer. Way, way faster and so much more efficient.
And this whole revolution gave birth to these amazing open source formats you might have heard of, Apache Parquet and ORC. I mean, these things are the foundation, the absolute bedrock of the modern data world. Pretty much any company doing large-scale data analytics is using them. And for a long, long time, they were perfect. They were the best tools we had.
But the world changed again. The rise of modern machine learning, of AI, is putting a kind of pressure on these tools that they were just never designed for. They're starting to crack. So, what was this amazing revolutionary tech for yesterday's problems is now actually becoming a major bottleneck for today's AI.
Okay, challenge number 1, data privacy. You've heard of things like GDPR, right? The right to be forgotten. It means if you ask a company to delete your data, they have to actually delete it. Sounds simple, but for these column-based formats, it's a nightmare. This quote from the ByteDance team just says it all. Deleting just 5% of their data to stay compliant means they have to rewrite hundreds of petabytes of data every single month. It's insane.
So why so wasteful? Well, the analogy they use is perfect. It's like having to rewrite an entire book just to cross out one sentence. Because of how the data is structured, to delete just one person's info, they have to read a whole massive data file into memory, write out a brand new version of that file without that person's data, and then swap the old one for the new one. The result? It creates about 20 times more work for the computers than it should. It's just a colossal waste of energy and time.
All right, that's one problem. But there's another, and this one has to do with just how complex AI has become. To get those hyper-personalized recommendations, the machine learning models need to look at a staggering number of different data points, or features as they're called, for every single thing you do on the app. And I mean, we're not talking about a simple spreadsheet with 10 columns. Just look at this. A single file used for training an ad model can have more than 10,000 columns. They call this the wide table problem. And these aren't just simple numbers. A lot of them are really complex nested bits of information. And here is the killer bottleneck. With the old formats like Parquet, if you want to read the data from just one of those 10,000 columns, you first have to read the description, the metadata, for all 10,000 columns. Think about that. It's like needing to read the entire index of a massive encyclopedia set from A to Z just to look up a single word. It makes the startup time incredibly slow. And this chart just lays it out perfectly. Look at the pink bars. That's the old way. As you add more columns, going from 1,000 to 20,000, look what happens to the time it takes just to get started. It skyrockets. It's a performance killer. But now, look at the red line down at the bottom. That's bullion. It's flat. Completely flat. It doesn't care if you have 10 columns or 20,000. The time to access the data is basically instant. So, the big question is, how did they pull that off? Let's dive into the solution ByteDance engineered to solve these huge modern AI problems. It's their custom-built data format, and it's called bullion.
All right, remember that massive wastefulness with deleting data?
Bullion's fix is just elegant. It's called in-place deletes. So instead of rewriting the whole book, Bullion performs a little bit of surgery. It finds the exact spot where the data to be deleted lives and just masks it. Puts a digital flag on it that says, "Ignore me." The rest of the file is completely untouched.
Okay, but wait, if you're just changing little bits and pieces, how do you know the file hasn't been corrupted? The secret sauce here is something called a Merkle tree, which is a really clever cryptographic trick. You can think of it as a hierarchy of digital fingerprints. When you change one tiny part of the data at the bottom, you only have to recalculate the fingerprint for that piece and the few fingerprints directly above it in the chain. You don't have to recheck the entire file. It's a super efficient way to guarantee the data is still valid.
Now for that wide table problem, the encyclopedia index issue. Bullion's approach is brilliant in its simplicity. It completely changes how it handles metadata. Instead of making you read the whole index, it builds a direct map in the file's footer. So if you say, I need column number 5280, Bullion can just jump directly to that column's information. And that's why you get that flat line on the graph. Lightning fast, consistent access, whether you have 10 columns or 20,000.
And it's not just those two big things. Bullion is just packed with all these other little optimizations built specifically for machine learning. Take this one for example, vector delta encoding. It's a super smart way to compress data. Think about your viewing history. It's a sequence of events. Instead of storing the full data for every single video you watched, this technique just stores the difference from the last one. It's a way more efficient way to store that kind of behavioral data, which dramatically shrinks the file size.
Okay, so we've been deep in the technical weeds here. But why does any of this really matter? What's the big picture? It's this. Solving these really fundamental nitty-gritty data storage problems is what actually makes the next wave of AI possible. When you have a smarter, faster data foundation like this, it unlocks so much potential. It means you can build AI models that are way more powerful and accurate. You get better ads and recommendations, sure, but it also means you can train things like large language models more efficiently. It makes AI-powered apps feel snappier, and critically, it helps us handle the future of AI, which is all about mixing different types of data, text, images, video, all together. And really, that's the key takeaway. Things like Bullion prove that the future of AI isn't just about building bigger and bigger models. It's also about building smarter, more efficient foundations for those models to run on. It really leaves you with a thought, right? We always hear that data is the new oil. Well, if that's true, then we're only just now starting to invent the sophisticated new refineries we're going to need to power the future of intelligence. Makes you wonder what's coming next.